Okay, so the first thing to show how TeXmacs works is just to show some paper that I wrote with the program. So let's go to let's say some recent paper that I wrote with Grégoire. So here you see. So here you see a paper. So if you look at it like this, it pretty much looks like a normal tech paper, but the magic is that you can just go inside and modify the paper here.
Is this styling of the paper, like for when you write for different journals or conferences, so you have different styles?
Yes.
Is the styling hand done for different styles by you, or can you process style files?
These are TeXmacs style files. So one thing I should also say right away is that TeXmacs is in no way based on TeX or LaTeX. So it's completely independent. Of course, one may want to import LaTeX or export to LaTeX, as well as to HTML or MathML, for instance, right? There's no reason that LaTeX is the only system we want to import or export. But the internals are completely unrelated. The only thing which is similar is that we use similar fonts. Even though nowadays there are other fonts which are also available. I can, by the way, show you that now publishers nowadays use the Stix fonts. Mm-hmm. So these are also now supported here. So here you see some of the text with Stix fonts, and you can also have the math done with the Stix fonts. So it.
What would you recommend based on typographic? Because
but you see, there are some things still which are not completely as they, yeah. So apparently, some which are missing. Don't know why this one is missing here, but anyway, it gives. This will, at a certain point, probably turn out to be an alternative to the LaTeX fonts, because they're still under development, the Stix fonts.
But they have many more code points than the TeX fonts, so maybe just that the mappings are incomplete.
Or well, some things are still missing, but it can also be that I didn't install it in the right way on my laptop, but we can discuss this later. Okay. In any case, yeah. So it's unrelated to LaTeX. You can now install also TeXmacs without installing a TeX or LaTeX system. So it's really independent. Okay. So let me show, yeah, how you would typically write something. So typically you would start by selecting a document style, depending on what you want to write. So for instance, a scientist would want to write an article, but a teacher might want to read an examen, for instance. So for an article, we would then simply start by inserting some title. And then if I press enter, I can enter my name. And then I can put some address. And here you see also that I can add additional information like the day, right? And then I go out of the title just by moving the cursor down, but there's nothing down, so I'm going to the right actually. And then I can type some abstract. Alright, I don't know yet. And then here in the toolbar, you see many things we can do, like starting a new section. And yeah, one of the basic principles of TeXmacs is that the user interface is redundant, so that it supports several types of user preferences. Some people like to type very fast with the keyboard, others like to use the menus, others like to use toolbars, others know already of LaTeX, for instance, and want to use similar commands as they used already before in LaTeX. So for instance, I can type \section, and if you want to process a LaTeX command, you have to press return, enter at the end, and then it just simply activates this LaTeX command. So there are some. So you also see that if I go on some of these items, that there are some little help balloons, so they inform you about what is going on. And you can also there's also an integrated help system. So for instance, if I want to create some equation, then I can just search in the help. I type create equation there, right? And then there are, well, several hits. Actually, in this case, it will be the second one that you will have to choose. And you see how to insert formulas. So there are 3 types of formulas, whether you want them to be displayed like this inside text, on separate lines, or in tables like that. So we can go back to the paper and use one of these things. And we're now inside an equation. Okay. Similarly, we can do theorem. And we have some, we can start typing some theorem, or proof. I can start typing proof. So of course TeXmacs is nice for typing mathematics. So let me start with showing how to type math fast. So first of all, basic symbols. So basic symbols, you can just type A plus B plus C, for instance, like that. And one of the main principles of typing symbols is that you have the tab key for making variants of symbols. So for instance, if I type A and I type tab, then I get alpha, which is the Greek variant of the Roman A. Similarly, if I type B and then tab, I get beta, and I can type B tab twice, and then I get the flat sign, which looks a bit like a B, and then cycle with tab among these possibilities. So this gives a way to enter symbols fast. Another basic principle is juxtaposition of symbols. So for instance, if I type minus and then superior, this will give you the arrow. And if I do a second superior, then you get an arrow with 2 hats. So there is no need to remember complicated names for symbols. Most of the symbols you can simply get them in a very visual way in this manner. For
the ligatures and the variant symbols, as well as typing tab, do you have some maybe like alt tab or something to give a more comprehensive list? keys. Like with A, you do not go to A line, and you do not have like a Russian B. So how do you, if you want to have longer lists?
Well, the longer lists are not, in my opinion, usually not very useful to have very long lists, because if you have to tab 10 times to get the symbol, that indicates that you would have preferred probably to do it in another way. So for instance, if you want to have, let's say, a blackboard bold B, you could either use one of these menus, but of course you can also just look what the keyboard, the shortest keyboard shortcut is in this case. So for the blackboard B, you see that you could type just BB, right? So BB, and that would do the trick.
There is a file with variants, super easy to read, and then you can change the order. For example, currently, I think if you type A tab, it becomes Greek A, Greek alpha. But actually, if you're doing a lot of vector maths here for the teachers at the lycée, you can remap it. So just tabbing gives you the bold A, and this is or with the small arrow on top of it, and this is super useful to make your typing very productive.
Yeah, and then there's another for the basic letters. There are the F5 until F8 keys, which give you most of the variants. So for instance, for having just a bold character, you just type F6 and then the character. If you want to have a calligraphic character, you type F7 and then your character. If you want to have a fraktur character, you type F8 and then your character. So this, with these combinations, also for instance, if I want a bold, so Greek can also be done with F5. So if I do F6, F5, then I get bold Greek. So most usual characters, you can get them very efficiently in this way. But the variant system is also useful for other kinds of symbols. For instance, if I type inferior and then tab, then I get the in sign, and then the subset sign, then a variant of the inferior symbol, then yet another inclusion, and this one, which are the brackets. So you can cycle between these possibilities, of course. And once again, if I do this one and then type equal, then you will get this one, and you again have variants for this one. Then I can do negation with the slash, and again I have variants for the negation. And then a last one is the arrow base sign, the @ sign, which is used for making circles, but also for putting symbols inside other symbols. So for instance, if I type plus now, I get the tensor sum. If I do times, then I get the tensor product. And with a variant and with dot, I can put the dot inside a box. Okay?
May I make one remark just for students? So one cool thing that is also easy to do is to have a menu. You can very easily insert a menu element that lets you change the variant scheme that is used. So you could have something that's style dependent. So while I was working a lot with Greek stuff, I would use a style file, a variant list that has Greek as the first tab, but when I would switch to vector notation, I simply choose in the menu, switch to bold, and then I would type A tab and it would become bold.
So you can swap between.
So this lets you define super finely tuned list of variants for applications, and you can switch them in the menu, or eventually even with the keyboard, or make it even probably conditional on the innermost environment. So have some behavior outside and some inside mathematics.
Yeah, it's nice to be able to add your own things on top of what's already there, so that somebody else can also use your keyboard. So
Okay.
Thank you. That's very nice to know.
So again, for other mathematical constructs, like fractions, you'll have both the keyboard shortcuts and the LaTeX commands, right? or the menus here. So of course I would use the keyboard shortcut in this case, which would be very fast typically for doing a fraction. The scripts are done in the same way as in LaTeX. So for instance, underscore will just make a subscript, and the hat will just make an exponent.
Yeah, recently there was a discussion in the mailing list about tensors where indices can be upper and lower in any order. So is there any good solution for this problem? So that I want R with first index upstairs, second downstairs, third upstairs, fourth downstairs.
Currently, you would have to write a macro probably for this. If you would want to do the thing, I would use phantoms. For instance, if so I would type, let's say, A, B, C, and then I would type exactly the same thing in the superscript. Okay, and then I would just make phantoms of the ones that I don't want. Did I do it right?
You should. I'm taking note of all these things so we can them and personalize in the evening or definitely macro work together and with
right.
If you want, you can connect to the place where I'm writing.
Yes, in general relativity is very common.
But it would, of course, be nicer to make a macro for doing this. If you, for people who would really like to have.
So the way you'd like to do that would be just to enter the indices and then have a command to move them up and down. Because sometimes you have a big expression and you need to change the up and downness on that.
Yeah. So basically, this already somehow exists, right? You can, for instance, why does this not work anymore? This should work, but maybe. Yeah. In any case, I can insert a superscript, for instance, like that. So this might be a suggestion for improving subscripts and superscripts, having some extra menu items for handling that. But
make them a table, so just like the table.
So maybe that could be a nice programming exercise for this afternoon for those who have not been programming TeXmacs, to learn a little bit about how to do that, to take this as a real well-defined problem and just do it together.
Absolutely.
Okay, we can maybe do that. Right. So of course we also have big operators. So here I'm just typing something. So and you can just select parts of formula. So if I want to, here pi, there are several types of pi. So if you mean the constant pi, publishers like to have the upright pi, which really says this is the constant pi and not just the letter pi for projections, for instance. Similarly, E, if you do tab twice, you get this E, which would typically be used for doing e power x, for instance. Okay.
So, is there a difference between a superscript and a power?
No.
So if I see, so if you're sending an expression to a computer algebra system, it will always be assumed that the superscript is a power?
Yes.
I see.
But you could define a macro which would render as a superscript and giving it a different semantics.
But it's like a contravariant index.
For instance.
Okay.
So parentheses. And there again, you have variants. So for instance, if I take these parentheses, then as variants, you would have the ways to make French intervals, right? This is just typing the square brackets and then right and then just do tab, right? It's the variant system. It also applies for this thing, which is logic. Now, of course, TeXmacs especially becomes nice as it comes to more complicated formulas, such as matrices, for instance. So let us type a matrix. So I started a matrix. I now insert a new column just with escape and then the right arrow. Then 2 times dots makes actually 3 dots, and then with the variants I can take the dots that I like here. I again insert a new column. Now I press return twice, so I inserted 2 new lines. I select the first line. I just paste it there. I insert some more dots here, and I change the things over here. Okay. Now the variants also apply to the structures I am in. So I can take with Control Tab, I can change a matrix in a determinant if I like so. And similarly, I can change a theorem in a proposition and so on. Right. And then of course you can reselect part of it, and we can also replace A's by B's, right? And then we can copy and paste. And then, yeah, let me copy and paste this thing again. Then I can take this part. And then, to be really nice, we can put a bold 0 here.
To be really nice, you should have diagonal dots.
Diagonal dots?
Yes, in the middle. No. In the middle of each rectangular block.
Here?
Yes, here. Yes. Oh, yes.
Okay, there you go. And then there are some things you can do in TeXmacs that you cannot do in other systems like LaTeX. I can, for instance, select some background color or even pattern. If I like to do such a thing, just to make it visually more clear. Yeah, this one is not that nice. Maybe I should take which one with take this one, for instance. It's maybe a bit better, right?
Joris.
Yeah.
This is very just. I'm trying to make notes of everything along the way, so I want to get us the. This is very slow in the X version.
Ah.
If the X version is going to be supported, the loading of the palettes is extremely slow.
Okay. But that's only the first time probably because of the pictures inside.
I'm not sure. I cannot.
And it also depends on your system, on how. Yeah, the pictures, especially in the X version, it relies on a lot of external software. So basically, if you have certain software installed, there will be some conversion going on if you display a picture, and this conversion may be slow. If you have another version or another system, then you may use a more native.
These are always the same, so maybe they could be cached.
Yeah, they are. They are. So it's only the first time that you will experience that problem.
Another remark on this is, well, TeXmacs has one of the most comprehensive systems to edit tables that exist, and it works very well most of the time. And matrices are an instance of tables. Something that came up in the mailing list. Is it possible to change the color of the borders at the moment? Or is this a missing feature?
Yeah, you cannot. But there. Yeah, that's a missing feature. Of course, if you really want to have all the borders in a different color, then you can simply select a different outside color and then change the color inside each of the cells. If you want something with a blue border, but indeed we might want to have something to change the. Another new thing where you're probably less aware of is the fact that I've been working quite a lot on adding more semantics to mathematical formulas. So one thing that you may already have noticed, we just saw this before, is that, for instance, for the pi, we have the difference between this just the letter pi and the 3.14 and so on, the constant pi. Similarly, in TeXmacs, there is a difference between multiplication and function application. So in LaTeX, for instance, if you type xy, then this would simply stand both for x times y and x applied to y, or just x next to y. So in TeXmacs, if you type xy, then xy will be regarded as an operator, not as x times y. So if you want to have x times y, you really have to type x and then star for multiplication and then y. Similarly, if you wanted to have function application, so f applied to x, for instance, then you would type f space x. And space bar would stand for apply to. And
is this spacing multiplication configurable?
And the spacing may be slightly different. You can, by the way, now there is a feature that if you do in document view informative flags more detailed, you put details, you can see, I don't know whether it's apparent here, but you see a small blue dot between the x and the y, just to distinguish between these two things. It will not appear on the printed version, but it will appear on the screen when you're editing. So
the question was actually, how could I configure the way this dot spaces, this invisible dot spaces that
you can modify it, but you would have to modify some internals. There's a file in TeXmacs in the scheme part inside mathematics. There's semantics. I have to check. Let's see. We go to program. So it's language then, and you have here something standard symbols. And here you see all the symbols which are defined in TeXmacs. So here you see all of them with their meanings and their spacing properties. So here you have spacing. Right. So here is the spacing of just the function application, for instance. Right.
Thank you. So, in the MathML working group, we realized that not only is there an invisible times, that we also need an invisible plus.
Yes, there are many invisible things. So, for instance, the invisible plus, all the invisible things, you get them by just putting the space bar behind the character you want. So for instance, if I want an invisible plus, I do 2 plus space, and I have an invisible plus. So this would typically mean 2.5. Okay?
for example, juxtaposition is done the same way, like comma, space.
Right. So, for instance, in matrix notation, you would have, for instance, I typed here A1, 1, but you might want to do this. Just don't have the comma, and then you type comma space 1. So this has the same semantics as a comma. So if you would send it, for instance, to a computer algebra system, typically you would still get a comma, but on the screen it looks. And there are some things which are not in MathML. You also have, for instance, invisible 0 and invisible. Well, there were some other ones. It's all explained in the new manual pages about mathematical formulas. I think there some of these common invisible systems. I listed them here. So here, function application, separators, addition, point, for instance, for +1, for the operator +1, right? Invisible brackets. Okay, so right. And
this picture can be really confusing. I know a number of people who got really confused by the comma space thing. They say, "Where's my comma?" And they just went down.
Yeah. Okay. So.
It's very difficult.
So this is.
I'm confused, but I didn't know, and I was thinking it was a bug.
Yeah, right.
You know, you put you want to separate two equations in the same display. Then you put a comma. You want to write the other equation. You put space and the comma.
Yeah, but then typically.
Yeah.
Okay.
No. Now I understand why. So I was thinking that it was a bug.
Yeah, I can see that people are used to typing spaces.
Yeah.
Life outside of technology.
The point with spaces is really the worst thing for mathematical semantics, because people learn to use spaces in the wrong way with LaTeX, for instance, and also with plain ASCII editing, where you would typically type, for instance, A space plus space B, for instance. That would be a typical thing I would do in a program, for instance. So in TeXmacs, this would be terrible to do such a thing, right? If I do this in TeXmacs, I type, let's say, A space plus space B. Okay, that will just be terrible. So definitely you will have to have a different habit in TeXmacs than somewhere else. It's still a question for me whether what should be done, what is most logical for people. This is, of course, the current way is fastest if you want to type semantic math. But do people really want to do that? That's a question. Also, for instance, if you decide that people don't want to type math with semantics, then it might be better that if you type, for instance, space plus space, that you would just have plus and just collapse the things.
Consider control space or off space or things like this.
Exactly.
No, but I think the right thing, I see the point of educating users. I am actually sympathetic to it, but what could be done is you have this mini buffer, which most of the time is not very prominent. Whenever something invisible is inserted, if it flashed, if something at the bottom flashed very briefly, instead of being written in black, invisible something inserted, people would see
something.
Yeah.
Not even popping up, but that I think that people have, this is TeXmacs, this is a structure, this is a feature, but it should be very evident in the interface that you have done something that has no visibility there, but it can have visibility in the interface. If in the mini buffer, instead of printing invisible plus, you put that in red or let it flash very briefly, then people will start associating that they have done something that is invisible there, but the program has registered it and taken an interpretation.
Right.
Yeah, I think that's really some floating stuff, the mini buffers or whatever.
That's a possibility. There are other possibilities which are having more information at the cursor position. For instance, that if you are inside the formula, that when the cursor is really inside, that there are much more, there will be much more clutter around with indicating how this formula is going to be interpreted, for instance. This would have the advantage that it's closer to the point where your eye is focused. But we can, of course, discuss about how to do this. For me, this is not clear. I'm playing around with it. So to really turn on semantic editing, you have to go to this mathematical tool item here, and to turn it on, the semantic editing. If you do that, you see here now the formula is marked. I will start a new formula. Because so basically, when the formula, as long as the formula is right, you will see green boxes here, and the green box will indicate more or less indicate the semantics, how things are being interpreted. So, for instance, if I'm on the plus, it will highlight the whole expression on which this plus operates. Okay, this is a sum with 3 items, and on each of the pluses I get this subformula. If I am inside the fraction at the very start here, I will have the fraction highlighted. If I do something like this, okay, here the comma, it is a comma, yeah, is a list of things. And this, yeah, the function application, it applies to this thing. Okay, so here we have a sequence of function applications. So there really is some kind of parser going on here in the background, who is going really to try to make some sense out of your formula. So here if the formula is recognized, like with these nice green boxes as you see here, then TeXmacs is able to make sense out of your formula and at least give it a syntactical meaning. So if you would send it typically to a computer algebra system, a sufficiently good computer algebra system, it should be able to understand the formula.
Currently, this also depends on having the interface from TeXmacs to the system be sufficiently good to do the right transformations, right? How many of them are semantic enabled?
Well, they are all, well, they are up to, yeah, maybe not for all the notations, but for instance, the Maxima plugin, it does a reasonable job. For instance, for instance, the ones that Andre wrote will be able to recognize sums, for instance, like notations like this. Okay, this will typically work.